Okay, so this question says, find all solutions using any method. So all solutions means, positive, negative, fractions, radicals, things that have i's, so even your imaginary solutions. But it also allows you to do it by any method. What I would recommend is going through and making sure that it's equal to 0 first before you decide what method it is. So if you look at number 21, it doesn't look like you can do it using the square root method because it has an x squared and it has a regular x. So the square root method is out, but pretty much any other method would work. It looks like on this answer key, Ms. Bacek decided to do it by grouping, or actually it's the complex ABC, which turns it into grouping. And so once you're done with your factoring, you just end up with 5x plus 3 equals 0 and x minus 1 equals 0. So when you solve each one of those, that's how you get this answer here. Now, if you were to do any of the other methods, like complete the square or even the quadratic formula, you're still going to get the same answer. It doesn't matter. These problems, they only have 2 answers, and it doesn't matter what method you use. It'll all get you to the same thing. So it looks like on number 22, once it was set equal to 0, this one looks like it would be a complex ABC, but if you made the list for 14, nothing is going to get you to 6. So complex ABC method is out. So that's why the quadratic formula was used. So you can see it right here. Quadratic formula is the one that works on every problem, even the ones that could be done using the square root method. The quadratic formula is especially for the problems that cannot be factored. So again, in Ms. Bacek's class, they do this step all at once within the entire quadratic formula. In my class, we do this off to the side and we figure it out first, and then we can determine what kind of answers we're going to get and how many we're going to get. So if you're in Paris class, we start pretty much at this step right here. We end up, because this answer right here, it gives you negative 20. So then all we do is stick it inside of the square root and then substitute in the rest of the problem and simplify it. But regardless of how you do it, in the end, you're still going to get down to this answer right here. So we should get the same answer no matter what.